All right, so this is the second practice problem review video using the SD plus rules from lesson 7. In this video, I'm going to go over 3 derivation problems. They're going to be problems 3A, 3C, and 3E from page 223 of the logic book. Now, these are not starred problems, so you also have solutions in the solutions manual if you want to just see something quick. Those derivations might be a little bit different than mine, but it's absolutely fine. They're probably both accurate derivations, and please feel free to ask if you have any questions. So the first problem is 3A, and what we've been asked to derive is A or not A. So again, we start with a main scope line with nothing on it, right? No premises. We have to do this using subderivation rules. You might think, since we have an or, that one thing we could try to get is A by itself and then add the negation of A. But there's no way that we can prove A by itself from no premises, right? These theorems are all truth functional truths. A is not a truth functional truth. So if you were doing a derivation and got just A by a derivation with a theorem and got just A by itself on the main scope line with no premises, then it means something went wrong there. So what I'm going to do instead is I'm going to assume the opposite of what I'm trying to get. That means I'm going to assume the negation of A and not A, right? A negation outside those parentheses as a premise for negation elimination. So if I can get a contradiction in here, I can drop off that negation and write A or not A on the main scope line. Now I've got to try to make an obvious contradiction here, right? I've got to pull it apart. So the first thing I see I can do is I can use De Morgan's. I can use De Morgan's on line 2 to get not A and not A, right? So that this is distributing that negation and flipping the disjunction to a conjunction. And then from there, I can pull out, right? Now I have a conjunction. That's really easy to pull things out of. I can get the negation of A from conjunction elimination on line 2, and I can get the negation of A also from line 2, right, via conjunction elimination. These two are a contradiction. You could do something like double negation, so you have the negation of A and A, but here we have a sentence, and here we have that same sentence with a negation on it, right, the combination of the negation and A. So that's enough for our contradiction, which means on line 5, we can finish this derivation and have A or not A by negation elimination from 1 through 4. Now this problem's a bit harder, right? We've got A or not A or B and not A or C. So I'm going to do the same thing because I see a disjunction. I know I can't get either side on its own. So I'm going to assume the opposite by adding a negation outside of parentheses of that whole big sentence. And now I'm just going to start working that negation through with the rules I have to see if I can get a contradiction, right? So the first thing I have is this disjunction as the main connective and the negation outside the parentheses. So I'm going to use De Morgan's, right? That adds a negation to each, that flips this disjunction to a conjunction and adds a negation to each side, right? So now I've added a negation of A, and I've added a negation to this whole bracketed side, right? The not A or B and not A or C. Now I see I've got a negation outside of a conjunction, right? Outside of the parentheses of a conjunction. So I'm going to pull that apart to make it a little easier to work with, right? This is a pretty big, cumbersome sentence. So I'm going to pull this out with and elimination, and now I'm going to see what I can do with it. So now I see that I can get, I can do De Morgan's again, right? I can flip this conjunction to a disjunction and attach these negations to each of these two smaller disjunctions. And now again, I see I've got a negation attached to a disjunction and a negation attached to a disjunction. So I'm going to do De Morgan's again, right, on each of those two parts. Right now I've got I've flipped this to a conjunction and added a negation to each side, and I've flipped this to a conjunction and added a negation to each side. So this is something that I am okay with you doing, which is using a rule at more than one spot in the same sentence. As long as it's clear where you're using it, it's not mixing up other things, and you're not using more than one rule at a time. So we've only used one rule here, and we've used it in two different spots. You can't jump straight from line 3 to line 5 using De Morgan's because that's got things layered over on itself. So, but it is okay for you to use a rule of replacement, here and here and on the same sentence, on the same line, as long as you're using just one rule. So now I've got this here, and I see I can use the rule distribution. Now, distribution is a rule that whenever I use it, I always have to look it up to make sure I'm moving things around correctly. But distribution basically tells you that when you have when you have a disjunction that has two conjunctions and you have one of the same conjunct on both sides, right? So we have double negation A as the conjunct here and double negation A as the conjunct here, then we can flip that to double negation A and the other two conjuncts together with the disjunct. Anytime you want to use the distribution rule, absolutely look it up, but it can be really useful for things like this, right? So now I have double negation A in a sentence where the main connective is a conjunction, which means I could get it out by itself. And I also have A with just one negation with the main connective as a conjunction on line 2. So I see my contradiction. On line 7, I'm going to get the negation of A by and elimination from 2. And on line 8, I'm going to get that negation of the negation of A, again from and elimination, this time from line 6. So there was a lot of SD plus rules there, just kind of following my nose and working those negations through because I saw I had negations outside of a bunch of disjunctions and conjunctions, and you can work with De Morgan's with that. And then since we have that contradiction on lines 7 and 8, we can get our whole theorem out by negation elimination from lines 1 through 8. So let's look at one more problem. Here we're trying to derive a biconditional, right? We're trying to get if A, then B and C, if and only if not B or not C, then not A. So what we're trying to get here is a biconditional. So I'm going to use the biconditional introduction rule. For the biconditional introduction rule, we have to assume the left side of the biconditional and prove the right, and then do a separate subderivation where we assume that right side and prove the left. So we've got our first assumption, right? We've got that left side of the biconditional, if A, then B and C, and we need to try to prove if not B or not C, then not A. So it's not clear how we can jump straight from one to the other, so I'm going to do another subderivation where I assume not B or not C for material conditional introduction, right? Because that's what I'm trying to get at the bottom of this subderivation, is this material conditional, if not B or not C, then not A. Now I can get not B or not C, or now I can get not B and C, right? This is De Morgan's from line 1. I have a disjunction with a negation on each disjunct. So I can flip that to a conjunction and move the negation outside of the parentheses. And now I see how I can get not A here, right? I've got the negation of B and C, and then B and C is the consequent of this material conditional on line 1, which means I can use modus tollens to get the negation of my antecedent. Remember, modus tollens works because we know if the material conditional is true and the consequent is false, then the antecedent must also be false, right? Because if we have a false consequent and a true antecedent, that material conditional itself would be false. So we now assumed not B or not C as a premise for conditional introduction, and we were able to prove not A. So on line 5, we can get if not B or not C, then not A. So that fixes this first half of proving our biconditional. We assumed the left side and we proved the right side. Now we need to do a separate subderivation where we assume that right side and prove the left. This one's going to be a bit easier because we already have negations involved. So I'm going to do De Morgan's again in reverse, right? I'm going to do De Morgan's again here, where I flip that antecedent to not B and C from not B or not C. We are allowed to do this. The rules of replacements are great because you are allowed to use them on just parts of lines, unlike any of the rules of inference. So now I've got a negation on my antecedent and a negation on my consequent, which means I can use this great rule transposition, right? You flip the order of the antecedent and the consequent, and you remove both of those negations. So this side was simpler, no extra subderivations, just paying attention to my rules of replacement. So now we've assumed that right side and proved the left as well, which means on line 9, we can do our biconditional introduction and say, if A, then B and C, if and only if not B or not C, then not A. So we've proven that these two sentences are logically equivalent, that each entails the other. And again, for biconditional introduction, we have to reference both complete subderivations, lines 1 through 5, where we assumed our left side and proved the right, and lines 6 through 8, where we assumed the right side and proved the left. So that's all for this video on just doing some theorems with the SD plus rules. I hope it's helpful to you. If you're still struggling with strategies for solving derivations, please go back and read that Strategies for Derivations in SD document. It's got, I think, 7 or 8 strategies on how to approach derivations. It's still useful even when you have the SD plus rules involved. It was written by an amazing past TA of this course. So that's it for new material for the derivations in section 2. So now we've just got to do a bunch of practice before the second exam.